Hi, and welcome to the KubeArmor office hours, where we are discussing what everyone is discussing these days, the Log4J threat vulnerability that has infiltrated last couple weeks the enterprise landscape, and everyone from Wired and Time Magazine and everyone else is covering this. And we're going to discuss how KubeArmor keeps enterprises safe with our security policies. Before we get to that, we invite everyone to go to the KubeArmor GitHub Repo, star our repo, and help boost and get boost awareness of what we're doing. And we invite everyone to contribute to the project. We're looking for all types of contributions from DevOps engineers, security experts, developers to come help. Even if you are new to the open source landscape, we invite you to contribute as well. We're looking for all types, whether it's helping documentation, improving our flow diagrams. If you have some graphic skills, you don't need to be expert. You just need to be better than what we have to make it better. Everyone is smarter when we collaborate. We don't have all the expertise in one spot, but we're bringing together. However, we do have two experts today on our call to discuss security policies and KubeArmor. We have Ravi, Kishor, and Vishnu Soma here today to bring us through the landscape. So I invite each of them. Ravi, you go first to just give a quick introduction of yourself and your involvement with KubeArmor, and then we'll jump into the rest of the demonstration. Go ahead.
Thank you, Jeff. Thank you so much. So I'm Ravi. Basically, I'm here at working in AccuKnox as a product manager and also as a contributor and maintainer for KubeArmor. So basically, we are managing KubeArmor policy template that we wanted to talk about today. Basically, what we wanted to talk about this, everyone is talking about like Log4J or RCE today we are seeing. Correct. So let's further ado, let me share my screen and we can go from here. Let me know when you can see my screen. Okay. It's visible, correct? Yeah.
Yep,
okay.
You're great.
So this is KubeArmor repo. If you just Google search like KubeArmor Log4J, you can see this. And what Log4J is about, since we all know it has been discovered in just few days back ago. But let me say, this is not something new that we are trying to cover up. Matthew told like on December 1st, we saw this vulnerability, but it was widely exposed till 9 days. But according to me, right, since I have attended the Black Hat USA conference, if you just look at this one, right? So in 2016, this is not just some new concept of JNDI exploitation. It was discussed in 2016 as well. And here we are, nobody listened, or maybe it's a feature, they don't patch it up, and now this is something we want to know. And who is affected? The first person, right? So right now, we have a lot of people or industry or stakeholders that is affected. Basically, it could trim down to the other vendors as well, like cloud provider. Everybody is using it. Log4j. So if you look at this particular GitHub repo, right? So take example of Apple, Tencent, or anybody, Twitter, right? So it's verified, and you can look into this, that it is vulnerable right now, right here, correct? So we have a lot of reference. You can go around and you can get us what it is actually doing, and a POC that it was vulnerable in the past, correct? So looking at the architecture, and I will not cover majority of time because here we have a Vishnu. I just want him to take over for later parts. So right now we will be just discussing, let me just explain the exploitation of Log4j here, and then we can go ahead with a sample application, how we can protect this vulnerability in the wild. Right now, let's suppose today it's a Log4j vulnerability, right? But what if somebody asks you in November, correct? So you won't say my system is completely secure, but it isn't, right? We all know that. So that's where the powerful feature of the KubeArmor policy templates comes in. It will protect you if, and in the scenario you don't know, you need the protection. Because attacker will not only just do a simple command on your PC. Eventually, he tried to leverage using MITRE, TTP, or other attack vector, right? So those we're gonna protect, and we support those protection using KubeArmor policy. So let's head over to some diagram, and let me just pull up a terminal here. Can you see my terminal here, Jeff? Right?
Yep. Yeah, I can see it.
Okay. So here we can clearly see the steps to mimic the vulnerability. So you can clone this repo. I have already cloned it. Basically, we need deploy this YAML file. So let's look into what is inside this YAML file, right? So it's image that is a vulnerable image thanks to the Log4J Spring Boot vulnerable server that we are using to protect it. To basically show this scenario, right? So once we have that YAML, then we can apply it, right? And it will create a pod and service along with it. And then we need a malicious LDAP server running anywhere, right? But it could be attacker controlled, or it could be you can also deploy it on your own PC. But here is the real, what I will say. Here is the real bug, or let's not call it a bug, right? It's a 0-day exploit, right? So you don't need to run this LDAP, or neither you need to have any kind of access over your running server. You can simply send a curl request and pass it inside headers and encode it in base64, and you can get it working. So let's do it. I have it already on my setup. Let me just show you what it's there, right? This is shortcut for kubectl get all. So as you can see here, my pod is running Log4J demo. It would look something like I have told already, right? If you just give a kubectl get pod or services, you will be able to see it. And we have exposed it to external interface. The public IP is this one. Once we know the public IP, right? Let's go over here and check, is it running or not? Yeah, it's running, right? It could be a typical your application, or for demo purpose, it's just a simple, non-verified application. It could be your different, application that you are running on server production, or basically you are running your Log4j API and core inside it, right? What we do need next is we should be having a Java installed so that we can run this particular jar file. So it's hosted. I have downloaded this inside this PC. So here it is. It's around 33 MB, I will say. Let's check. Yeah, it's 38 MB file. So once you have it, right, you just need to run it. And here you need to supply your private IP. Private IP you can query using hostname. If you have multiple NIC card, you can use any of them. But let me use this particular one. So let me run Java, or I can use this command under command, right? It's a old trick, so anybody can use it. Once it is up and running, right? This PC, I have it. Let me just show you the IP before running it, right? So curl, if I enter check IP, you see my IP is different right now, correct? And for this PC, my IP is different. This one is the IP, okay? Now, let me again initiate the malicious JNDI server. And on this hand side, right, let me run Log4j The command to run is this one, bash, and you can execute typical model, how you can execute into any container. Let's try to run watch, and I will check whatever the directory is creating inside the temp file. Why temp file? Because we are using in our payload base64 encoded value. So if you just look at, let me decode this. Okay, I encoded it again. So what it will do, it will create a file called pwned inside temp directory. Okay, right now I'm in another, my application is running on production on Kubernetes anywhere. It could be Docker or it could be on Kubernetes anywhere. It doesn't matter. And my malicious LDAP server is running somewhere else, or attacker controlled LDAP server, correct? Now I can just hit a curl request. So what curl request should be having as per this documentation is this one, right? You have to supply the victim IP address here, and then you have to supply the malicious JNDI server. So we have those IP, correct? Let me just pull up it, and can you see my notepad as well right now, or no?
We can't see the separate notepad, just the
Okay,
the
I'm
README.
just, yeah, I'm just editing it. Let me, I will post it. Okay, I think I forgot, but let me look up it. Okay, let me just do a kubectl get all to just check the IP. I just forgot, sorry about that. So the public IP is this one. Let me use this. And the malicious server IP, I will be using external IP here. Note here, we are using external IP, not the internal one. And yeah, one more thing, since it is written in documentation, if you are using external IP, make sure you have a firewall rule that allows traffic from and to, okay? So I have edited it, what needs to be edited, and let me just run it here. So this IP is my workload IP, service IP that is externally exposed, and this is malicious IP. As soon as I hit enter, you see here, it's a file created, right? And that's the RC, right? You can, now what you can do, there are a lot of possibility. I don't need any interaction with the running workload, nothing I needed. Right now, an attacker can copy my password, or he can reverse open a TCP connection, those things, right? There are unlimited possibilities. How are we going to solve it? Before, like, everybody knows, right? Everybody is patching Log4j. Let's say once they know it, then they are patching it. But what if the same scenario I told you, right? What if you don't know this is a Log4j? Somebody executed inside your terminal and he is trying to, you know, reverse open a socket connection, and even he would try to read any file, or, you know, deploy, create any file. So those scenario could be protected using KubeArmor. So that is what we gonna discuss today with Soul Pickle application. Vishnu, do you want to take over from here?
Yes, yes. Thank you, Ravi, for
Yeah.
that. Yeah.
Yeah,
Thank
and
you.
Vishnu, just do a quick intro of yourself. I think this is your first time on our office hours, so just give a quick hello and introduce yourself and your role with us, and then go ahead.
Yeah. All right. Yeah. So hey all. So my name is Vishnu, and I'm with AccuKnox. I'm a security engineer, and we have been contributing to KubeArmor in respect to the policies creation and validations of the policies. So let me share my screen. Yes, wait a moment. I hope it's visible, right?
You're good.
Yes.
Yes. Okay. So yeah. So to adding on to what Ravi said, right? Since RCE is a very serious vulnerability which can happen to anyone. So we will be taking a look at application which is mostly written in Python and has an insecure deserialization which will result into an RCE. So before we taking a look at the application itself, right, there is a simple thing that everyone needs to understand. Like when we are coding, right, most of the times we developers, we use external or third-party packages. Like we import them to our code to make sure that our workflow is completed, or we don't have to write millions of codes to just bring in some external functionality to our code. So one of these imported packages in Python is the Pickle module, which basically does a serialization and deserialization of data. Yeah, let me just go to my next slide so that you can get a better understanding of what a serialization and deserialization does. So this is basically what the serialization is like. When we have a data to be transferred, right, an object to be transferred to the client or any person, right, we can just make the data into a stream of bytes so that it will be easy for us to transfer via network or just store it in a memory, database, file, wherever it is. And once the client or the user wants to see the entire data, right, he can just use the packets, like small pieces of data which are present in the file, database, or wherever it is, and just take it and deserialize it and make the object in his hand, right? So the issue that might happen, right, when we use the serialization and deserialization is that when we don't use a zero trust, or we blindly trust the source from where the serialized object is coming, right, then there may be a possibility that the data which we receive, which we are going to deserialize, might be an exploit or an exploit code. So that will lead to whatever Ravi said, something like an RCE or uh, a code injection to our particular module, right? So that brings us to the scenario which we are going to use and demonstrate so that you can get a better understanding on how deserialization, insecure deserialization might cause an RCE onto any application. Right. So the application which we are going to show you is purely based on a Python. So the backend for this application is a Python server, and there is a PHP code running inside that one so that you can get a UI. So in this scenario, the attacker is going to just do a recon, right? He's going to do a recon onto cloud applications, waiting for some juicy stuff to pop up, right? So for some juicy stuff to get outputted. So once he tries this recon and gets an IP address which is serving with the Python web service, right? He can use the serialized exploit code, right? If there is a uploading feature, or if there is a username password entering feature, then he can just use the serialized exploit code to try and execute into the root shell itself. So here, the serialized exploit code will be uploaded to a particular website, and then it will be, we will be getting a RCE, right? A root shell. We'll be getting a root shell popped, and we are going to take over the entire system using that. So yeah, let's move on to a demo, right? Before we come into the MITRE section. So let me just take. Yes, so we already have published a blog about this. You can take a look at the docs.AccuKnox.com, where we published about the RCE in the Pickle module itself. So the microservice which we are using is fairly simple, which only has two modules. One is the Pickle app itself, which is running on the Python, and it is hosting a web page. And there is a MySQL backend DB, so that anything the user is going to upload will be stored into the database itself. So you can have a look at the code in this repo, and we will be taking the k8s.yaml to deploy our vulnerable web application, the Pickle applications to our code. So let me just pull up my terminal and copy this command. So I'm gonna deploy it into a namespace. Mm, So we just deployed the application. Let me show you what all we deployed. Right, so the application is deployed and you can see that there is an external IP which exposes our application to the web. Let's take a look at what the application itself is. So if you check, right, it's just an uploading and sharing site. So we can choose a file and upload it. And you'll get a message that it is going to be uploaded and you will be getting it shareable link so that you can share it with whoever you want. So let's see how the exploit is going to happen, right? So let me just show you the exploit which we are going to use. So this is basically a Python program which makes use of the Pickle module and creates an exploit out of it. So what it does is it creates a symlink with the F folder inside temp and then creates a shell and then attach it to this particular IP address onto this 4444 port. So yes, before that, let me just spin up our NC port. Let me just deploy it. Let me just deploy the deploy. Let me just go ahead and pick it running. Container creation. Yeah, okay, so it's deployed, right? We need an external IP so that our reverse shell will be, we'll get the reverse shell, right? So let me just expose this to the web so that we can get a reverse shell. Yes. Since I told you, right, we are using the port 4444. That's why I'm exposing that particular port. If you have a virtual machine, you can just use that and make sure that the port 4444 or whatever port you want to expose is exposed, right? Since I'm going to use the Kubernetes itself to deploy the application and create the shell inside it all. So let me, yes, okay, no time out. Now this service is exposed. Making go back and see whether we have everything ready. Yes, so you can see that I did deploy the Netcat port and the external IP is getting spinned up. Let me just again see whether it's there. because of this terminal. Just, so you can see that it's already deployed, and we got our external IP, right? So we have to go back, change the exploit with whatever IP we got from this particular thing, right? So that it can connect to the netcat port itself. So let me change the IP here. Create the exploit. So you can see that it shows the base 64 encoded value for that particular exploit, right? Let's show you. You can see that it's created within a parrot.pkl. So I'll be uploading this. Before that, let me just execute into the code. Terminal, I'm not getting it. Okay, we can. Yes, so I'm already in this netcat port. Let me just type in nc minus lnvp and the port number. So you can see that it's listening. Let's try to upload the pkl file which we created and see what happens. Yes, and you can see, right, once we uploaded the file, we got the reverse shell active, right? So let me just show you that we are indeed in the same pod itself, right? You can see the host name is Pickle app, which is the same name of our pod, right? So that means we successfully exploited into the pod itself. So the next thing would be to protect from this, right? We can see that it's still loading because it's running the exploit in background. So we don't know how to, or who might gain access to our ports, thereby exploiting our port and gaining the entire system, right? So one thing we can do is we can go to we can use KubeArmor, deploy a policy which says explicitly says that these kind of uh, issues will not arise, right? Once we deploy a policy, so that we can, again, if we are not even using the zero trust model, right? If we have KubeArmor installed and if we have a policy in place, we don't have to worry about the stuff like importing packages and writing a code which may not be secure enough, right? So KubeArmor is going to protect these kind of issues and make sure that your workload is safe and nobody can gain an root shell access to your pod and thereby taking control of your entire Kubernetes structure or cluster. Right, so let's see what we can do, and we'll be taking a policy. Yes, so you can see the policy here. This is already merged to the KubeArmor policy repo. So I'll be taking this policy and let me just open up another terminal and I'll apply this policy. Yes, let me just take the namespace. forgot to change the namespace. Let me just edit that policy. Edit that policy. Just paste here. But I think my internet is a bit slow now. That's why it's taking time to connect to the server and get the resources. Yeah, so you can see that I just created the policy 71 seconds before. And even if we have access to the root shell, right, via the netcat reverse shell, right? Let me just type in host name again. You can see that it directly blocked the use of this particular binary, right? And if I go back and see, okay, the logs, right, for my Pickle app is running on this particular node. I take the KubeArmor, which is running on this node. Yes. So I'm going to grab it with the policy name itself. Wait, let me just make it again. Let me just right. The moment you executed something onto the netcat reverse shell, right, you are getting a log which says the particular policy is affected and an operation is indeed uh, denied, right? So let's say like we just close the connection and again we'll listen for it. Let's see what happens if we try to upload it again, right? If it's the first time the attacker is going to upload it, let me just upload it once more. And yes, right. Yeah, this time you can see that the entire command, right, which we use to create the exploit, it is getting blocked. So it's not even going to uh, give the reverse shell, right, to the netcat port. And you can see that it says the file was successfully uploaded, but no exploit was happening. So this way we can, even if we write an insecure code by importing Python or any kind of libraries, right, we can use KubeArmor to protect them without making any downtime to our applications in Kubernetes and secure it. Yes, let me just go back. Yeah, so in this particular scenario, right, if you map it to the MITRE, right, if you map it to the MITRE, you can see that we used reconnaissance, the active scanning to get the application which is running on a Python web server. And once we get that, we used we used the initial access in which we exploited the public facing services, and the execution happened via Python's module, which is the Pickle module itself. And we were able to get a reverse shell, that is an SSH shell, via the lateral movement, and the impact would be total resource takeover. Yes, that's it, Jeff.
That's awesome. Thanks so much for walking us through that. I was wondering if you touched on this briefly, but I was really interested to hear more about how essentially with KubeArmor, by establishing the policies ahead of time, developers can be more confident about pulling in these third-party libraries, which it's just an unknown threat that may or may not live in these. And so by establishing the rules ahead of time through these security policies, developers can be more confident to pull in and test and use these libraries. Is that essentially part of the concept of what you displayed there?
Yes, precisely. Like when we take a look at the pod itself, right? The pod doesn't need to execute a binary, right? The only thing that it needs is the the Pickle module, and which the access to the MySQL database. So apart from that, there is no need for the pod itself to run any kind of binary. So when we write a policy which blocks the access to all these binaries, right, or make sure that the Pickle application or the Python application is only accessing whatever it needs, right? Essentially, that makes it more easier for the developers to import a library so that they can work with it. They don't have to worry about the consequences or the security issues that might arise, and they can continue developing the application without overhead, right? So KubeArmor takes away these kind of overhead and make sure that your application is well protected.
Yeah. So what with the security policies themselves, we have a few of those that live on the repo with KubeArmor already. Can you talk about what is the type of developer or DevOps security expert out in the community that we're hoping to come in and help build out what we already have on the repo? So those are already available for anyone to use and download and get a head start on anything they're working on. What kind of expertise is really helpful to get those up and running? Or maybe is it the lack of expertise that kind of helps bridge with these? So just really from the community broadly, who would we like to help come out and help and build these policies with us?
Yeah, so basically, since KubeArmor and this policy template is open source, right? We do not require any special knowledge that you needed to have to contribute. That's the beauty of the open source, correct? So just let me pull up a contribution guide so that I can just guide you like how one can contribute, or if they wanted to contribute, right? So let's say we have a lot of issues open. You can look into any issue and give us your opinion there, right? Let's say if you don't know anything, correct? Just try our KubeArmor and help us in documentation, whether you are able to successfully install it, you faced any problem. And if you are like, best will be to pick up a good first issue that you can try use go ahead, install KubeArmor, manual installation, automated installation, anything, right? So it would eventually help us to groom in many other ways, right? Those help we really appreciate. For if you're from coding background, say developer, they can contribute in, like we are right now facing in client Go program. We are trying to import it. You can contribute there. And you can contribute even in if you are kernel programmer, you are more than welcome to help in supporting the older kernel releases so that we can enhance our support for RHEL and CentOS, which is majorly used in cloud provider nowadays, right? Even since starting. We have a contribution guide. If in any scenario you need help, you are more than welcome to join our Slack channel, open an issue on KubeArmor. We are more than be happy to assist you there. And
also feature requests, right? If the project isn't doing what you like, you don't have to know how to build it to know that it's you would like to see this. Those are things we can throw out there and work collaboratively to build it, right?
Yeah, definitely, Jeff. This is this I will say this is a good point that you put up. Suppose we can think of KubeArmor as this we can protect, and these are the scenario, right? But if you have innovative idea and you wanted to contribute and you wanted to add the feature, I think you should do it. You should go ahead, do it right now. Open a pull request, open issue, help us with this. So did it answer the question, right, Jeff?
Yeah, absolutely. Yeah. So that's all the questions I got on my end. Are there any last thoughts that we should have touched on before we end for this office hour for today?
Yeah, pretty much right now we are concentrating on policy template that we want. Since policy template is something that the more the community support we will get, right, the more we can help here. So right now it's on growing. We want to hear the help of community, like as I did discuss in previous call, and right now even I'm discussing it, correct? So it will be of a great help if somebody can contribute here. We have it, so you can protect your workload. It's open source. So basically what we are trying to solve here, right? Developer need to do code, right? He shouldn't be worried about, security, correct? So let KubeArmor handle it, runtime protection. Cloud, if something attacker is already in your environment, you don't have to worry about it, right? Let KubeArmor handle it. So these are the problem we are trying to solve majorly here.
Excellent. Yes, let KubeArmor handle it. That's a good way to end our call for today. Thanks everyone for being here, and our two panelists for today. So we'll be back in a couple weeks to discuss more topics out there in the security landscape. So have a good weekend, and we'll see you out there on the repo.